Assalamualaikum. This is a sharing video on how to answer the previous test for this particular subject. Okay, yang all jawab last time lah. Okay, so kita akan tengok satu-satu contoh soalan yang diberi dan saya cuba explain lah apa yang perlu dijawab bergantung kepada soalan yang ditanya lah. Alright, so the first one, dia minta explain the basic concept of a capacitor and draw a proper figure. So, kalau tengok markah kat sini ada dua kan, meaning that definitely satu markah untuk explain, satu markah untuk drawing. Okay, so walaupun nampak macam tak banyak tapi markah sikit-sikit pun membantulah kan. Right, so basic concept dia adalah you kena explain capacitor tu apalah sebenarnya. It's a energy storage element consisting of metal plate that is connected or in parallel with each other, and it is separated by a what we call as dielectric material. So you can prove your explanation based on the figure that you draw and then make sure you label lah gambar dia. Okay. So seterusnya, describe the working principle. So in order for you to describe, you have to, sorry, kenapa dia tak hilang? Okay. Describe the working principle. Untuk describe, if the description that you want to tell can be easily explained by drawing, then boleh guna gambar lah. Contohnya di sini untuk working principle ni, you have to mention regarding the plate that is connected with the voltage source, for example. Okay, so kalau untuk capacitor ni, the plate that is connected to the positive terminal will have a positive charge, and the plate that is connected with the negative terminal will have the negative charge. And the energy is actually stored in the electric field. Okay, markah dia semuanya, tiga-tiga markah ni sebenarnya explanation, description, you have to describe. Walaupun gambar ni tak ada markah, tapi actually if you let's say salah statement tapi gambar ni betul, lukis ni you masih dapat markah ni walaupun tak full mark lah. Contohnya. Okay, untuk soalan B, it is based on waveform yang diberi. Okay, then you have to express the mathematical expression first, lepas tu dapatkan sebutan I. Okay, so ini adalah graf yang diberi. Okay, let me write it here lah. V volt, and then here is T in millisecond. So that's why every time kalau you dapat graf ni, make sure tengok betul-betul unit yang diberi. Kadang-kadang dia letak millivolt saja nak bagi you keliru ataupun ni lah, nak bagi you alert lah sebenarnya. Okay, so 12 macam tu, straight, and then kita. So untuk baca graf sama macam kita buat dalam example masa kita belajar chapter 1, kita tulis dia punya coordinate. Since this is a linear graph, dia bergantung kepada y equals to mx plus c lah. Okay. 6 milli and kosong. So first kali kena baca dulu VT dia. Okay, sebab ada 3 graf yang berbeza, so akan ada 3 senggat lah di situ. From 0 to 2, Y dia V lah, V equals to M, how to calculate M? So it's 12 minus 0, y2 minus y1 divided with x2 minus x1. 2M minus 0t plus C. But C dia kosong lah sebab dia intersect dekat kosong. Y-axis dia kosong. So 12 bahagi 2 mili is not 6 but 6,000 T. Okay, so untuk 2 mili ke 4 mili sebab dia straight line, so V sama dengan 12 volt je lah. Okay, and the last one for between 4 mili to 6 mili, V equals to 0 minus 12 divided with 6 mili minus 4 mili T plus C. Okay, yang ni take note lah, kita akan ada C So kat sini kita dapat negative 6,000 T plus C. Untuk kita tahu C berapa, kita boleh buat unjuran ke atas ataupun kita ganti dengan salah satu koordinat, sama ada koordinat yang awal atau koordinat yang akhir. Let's say kita ganti dengan koordinat awal, which is 4 mili 12. So V sama dengan 12, negative 6,000. T dia 4 mili plus C. So daripada sini kita tahu yang C adalah 12 tambah dengan 24 kan. 4 mili darab 6,000 dapat 24. So bawa ke sebelah kiri, it's plus. So C is 36 volt. So definitely equations kat sini adalah negative 6,000 T plus 36 volt. Okay. Itu baru baca. Kita baru baca. Then, soalan pertama tu dia minta sebutan I. So, I we know untuk capacitor equals to C dV dt. So, untuk kira I dia berapa, kita kena guna ketiga-tiga ni lah. So, IT equals to from 0 to 2 mili. Okay. C dia 5 kan. 5 micro. DDT, your 6,000 T. Okay, yang ni you akan dapat, differentiate this one, you dapat 6,000 times with 5 micro, you get 0.03 ampere. For 2 mili to 4 mili, 5 micro DDT, your 12 volt. The differentiation of the constant is 0. So 5 micro times 0, you will get 0 ampere lah. And the last one, between 4 and 6 mili, 5 micro DDT, your negative 6,000 plus 36. Okay, differentiate this one, you get negative 6,000 times with 5 micro, you get negative 0.03 ampere. Okay, then you can plot the graph. This is I. So this one is depend on you. Whether you want to put it in ampere, then it is 0.03 for above and below a negative value over here. If you want to put it in milliampere, also can. For example, if it is in milli, so it's going to be 30 milliampere, right? And this one is negative 30. Between 0 to 2, it's 30 milliampere. Between 2 to 4, it's 0. In between 4 to 6, it's negative 30 milliampere. This is your T millisecond. So this is the answer for that first part of the question. Okay. Next part of the question. Draw the power supplied to the capacitor. Okay. Draw the power supplied. In order to calculate the power, okay, firstly, let me remove this. P, we know that P equals to I times V. Okay, so for that particular question previously, what we can do is that we just need to calculate for each part of the graph as well. For between 0 to 2 milli, P equals to, the I is 0.03 or 30 milli times with V. V is 6000 T, and it is 180 T watt. So from here, you can know that you can substitute the T. If for T0, P will be 0. For T equals to 1 milli, P equals to, just substitute over here 1 milli. You will get 0.18 watt. For T equals to 2 milli, because it's for between 0 to 2, right? So P will be 0.36 watt. Okay, so the next one is for 2 milli to 4 milli. Okay, P equals to IV. So the I is 0, right? And the V is 12. So definitely you straight away going to get 0 watt between 2 to 4. So at 2 milli, it's 0. 2 milli, P equals to 0. T equals to 3 milli, P equals to 0 as well. At T equals to 4 milli, P is also equals to 0 watt. And the last one is for 4 milli to 6 milli, P equals to negative 0.03. This is I, and this one is negative 6000. The V is negative 6000 plus 36. So what you can do is you can expand this. So you will get over here 180 T minus 1.08 watt. Then you can substitute for T equals to 4 milli, P will be negative 0.36. For T equals to 5 milli, P will be a negative 0.18 watt. For T equals to 6 milli, P equals to 0 watt. So based on the value that you get over here, you can draw the graph of P. Okay, T millisecond. This is P in unit watt. Or if you want to put in milliwatt also can. Okay, between 0 to 2, 0, 0. To be 0 for 1, 0.18 over here, 2, 0.36 watt. Okay, and then at 2 as well, it goes to 0. 3 is also 0, 4 is also 0. Going to be here. And then for 4, it is not just 0 for this one, it is negative 0.36. So it is over here as well. And for 5, it's negative 0.18. And for 6, it is 0. So this is the graph for P. Okay. And the next question, draw the energy. Draw the energy. Okay. For the energy, we know that W equals to 1 over 2 CV squared, right? So for 0 to 2 milli, W equals to 1 over 2, C is 5 micro, V is what? 6000, right? 6000 T squared. So over here, if you simplify, you will get 90 T squared joule. You can substitute 40 equals to 0. W will be 0. Okay, substitute 0 over here. 40 equals to 1 milli. W will be 0.09 millijoule. 40 equals to 2 milli. W is 0.36 millijoule. Okay, so because the graph is quadratic equations, so you know that it's somehow graph bentuk lengkuk lah. Alright, next is for between 2 milli to 4 milli. Okay, W equals to 1 over 2. C is 5 micro. V 12 kuasa 2. Kat sini straight away you akan dapat 0.36 millijoule. So 40 2 mili, W 0.36 mili. Untuk T 3 mili, W pun 0.36 mili. And untuk T 4 mili pun W masih sama. Okay. Last one for between 4 milli to 6 milli. W equals to 1 over 2. C is 5 micro. V is negative 6,000. T plus 36 square. Okay, yang ni you kena expand lah. Expand and then darab dengan 5 bagi 2. So kalau ikutkan equation sini, you akan dapat 90 T kuasa 2 tolak 1.08 T tambah 3.24 mili. Okay, substitute. Untuk T 4 mili, you akan dapat T ganti dalam ni 4 mili, 4 mili. You dapat W 0.36 joule. Untuk T 5 mili, you dapat W 0.09 millijoule. Sini mili Okay, millijoule. And then for T 6 mili, W sama dengan, you ganti dengan 6 mili over here and here, you will get 0 joule. So graph dia, okay, WT unit joule, you ada plus minus value ke? Tak ada, semua plus. Maximum value 0.36, you also have value 0.09 and 0 of course 0 to 2, 2 to 4, 4 to 6. This is 6 over here. This is T millisecond. Kosong kedua, dia start kosong and then it goes up to 0.36. Okay. Lepas tu 2 ke 4 semua 0.36 and then millijoule. And then daripada 0.36 it goes down to 0. Okay, di mana pada 5 ni dia 0.09 mili. So this is the graph will look like to that particular question. Okay. So hopefully you understand how to answer that question. Soalan seterusnya ni adalah untuk chapter 2. Chapter 2 ni sebenarnya hari tu saya dah inform kan masuk untuk source free apa yang masuk, untuk start response apa yang masuk. So sepatutnya you tahulah nak jawab macam mana. Okay, so for figure Q2A, it opens at t equals to 0 second. Determine voltage for t less than 0, t more than 0. Okay, so untuk figure Q2A, ini kita punya circuit. Okay, so let me draw this first. You ada 12 volt, 3 kilo ohm, and then you have 6 kilo. You have 3K over here. What else? 2K, and then over here is 150 micro. Okay, so ada switch okay, switch kat situ, dia buka pada masa kosong. Okay, switch is here, it opens at t equals to 0. So for t less than 0, dia dah, sebelum dia buka tu, dia dah mencapai keadaan steady state. So what happened to the capacitor in steady state? Open circuit kan. So circuit kita akan berubah jadi, kat sini open, and this is VC at time 0. Okay, the rest of the circuit masih sama. So kita nak cari this VC0. Okay, since this is open circuit, there is no voltage drop dekat 6 ohm. 6 kilo ohm lah. So disebabkan itu, kita boleh cakap juga VC0 sama dengan V dekat 3 kilo ohm. Okay, sebab kat sini tak ada voltage drop kan. So plus minus over here will be the same as plus minus over here. So daripada sini, kita boleh sebenarnya buat what we call as voltage divider lah. Guna VDR, nak cari V3K ni. So V3K macam mana nak cari? V3K, so 3K bahagi dengan total 3 tambah 3 tambah 2 darab dengan V source lah, which is 12. Okay, so 3/8 darab 12. Kat sini you akan dapat 4.5 volt. Okay, straight away terus dapat. Markah berapa tadi? 4 kan? Sorry. Let me check again. 4 markah. So next kita kena jadi for t more than 0. For t more than 0, okay, dia dah buka. Okay, bila dia dah buka, circuit you sekarang yang tinggal cuma this part. Okay, 6K, 3K dan sini 150 crop. Alright. Okay, ini V yang you nak cari. Okay, this is the case of what? Source free kan? Source free RC lah. Okay, kenapa kita determine dia punya jenis circuit? So that kita tahu kita nak pakai tau yang mana satu. Bila kita tahu dia source free, definitely V dia adalah V0 exponential negative T over tau, yang mana tau should be RC. So daripada sini kita boleh kira lah value R dan C diberi. R ni R equivalent. So disebabkan ini, kita boleh kira R total dia berapa? 9K. C 150 micro. Kita dapat tau 1.35 second. Okay, so V0 ni kita dah kira. This one. So V finally is 4.5 exponential negative T over 1.35. Ataupun you nak bawa naik 1.35 ni, dia akan jadi 4.5 exponential negative 0.74 T unit volt. That's it. Terus dapat jawapan dia lah. Jawapan kepada soalan tu. 6 markah. Okay. Untuk the last question, determine the current that flow through the inductor in the figure Q2B. Q2B, this one. Okay. So, untuk that question, saya lukis circuit sekejap The original circuits given to you 1268. Inductor, and then 12 ohm. Then you have the switch. Dia buka at T0. This is 12. So ini graph, circuit yang diberi. Ini RL circuit lah. And this is a step response RL. Okay, so step dia sama, cari 40 less than 0. 40 less than 0, this thing is close. Bila close, a resistor parallel with a short wire, you can ignore 12. So your your circuit cuma ada ini dan ini. Dan what happened to inductor dalam keadaan steady state? It is short circuit. So this is the I0 yang you nak kena cari. It's just 12 divided with 6. 2 ampere lah. Okay. Terus dapat I0. And then for T more than 0, redraw the circuit. You have 6. You have inductor. And over here dia dah buka. So 12 ohm ni dah ada di sini. Okay. And you nak cari IT kat sini. Okay. So, daripada sini, you boleh tahu yang circuit ni adalah circuit step response sebab ada source and then RL. So, disebabkan itu, you kena guna equation I equals to I infinity plus I0 minus I infinity exponential negative T over tau dan tau equals to L over R. Sebab ini RL circuit. So, you dah ada value ini, you perlu cari tau dan juga I infinity. Okay, tau L over R. Macam mana nak cari R? R is R equivalent that you look from the inductor terminal when all independent sources turn off. So, 12 ni turn off dengan cara short, yang tinggal cuma 6, 12. Dan ini adalah terminal U, terminal inductor lah. R equivalent. So 6 dan 12 ni series lah. 18 ohm. So L is 8 divided with 18. Okay. 0.44 second. Okay, that is tau. Untuk I infinity pula, you kena lukis balik circuit when T approaching infinity. So you ada 12. Now, what happened to inductor? Should be short. Okay, ini I infinity. So, I infinity equals to 12 divided with 6 plus 12. And total R is 18. 12 bagi 18, you dapat 0.67 ampere. Okay, dah ada semua, masukkan je. 0.67 tambah 2 tolak 0.67 exponential negatif 1 per 0.44. 0.67 2 per 3 0.67 tambah dengan 1.33 exponential negatif 2.25 T. Okay. Ataupun you boleh juga letak 2 per 3 tambah 4 per 3. Up to you lah, you nak tulis mana satu. So, di sini you boleh factorize 2 over third, 1 plus 2 exponential negative 2.25 T unit ampere. So, this is the final value for the questions. Okay, jawab yang ni boleh terus dapat the full marks lah, which is berapa? 10 kan? Alright. So, that's all for sharing on how to answer the test. Okay, thank you.